This is a talk about topic modeling, and instead of tagging documents as one normally does with a topic model, what we're going to do is search instead. And I really only have one sort of major point to share with you, so I am going to go through this very quickly. But there's a GitHub repo with the actual code in it, and you can run through that and try it out on your own. So yeah, I work for a social media platform called Unified for activists and organizers. You can go ahead and take a picture of that if you want to check it out. We do some really cool things around, get out the vote and civic data. This is the team, very small team. I'm the lead data scientist, but I'm also the only data person. It's just a polite way of saying one. And Linux is the cat. And that's, he appears in this presentation quite a bit. So why are we talking about topic modeling as search? I was given this mock-up by our CEO. He wanted to just discover trending topics on our social media platform and share that with our users. And in the back of my mind, like all of you are doing right now, I'm thinking, cool, 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 topic model, tag the post, this is going to be easy or hard, I don't know, but it's a topic model. But then when I really dug into this mock-up and looked at it, I realized, like, wait a second, I can tag all these posts, but these topics are changing all the time, sometimes daily, right, hourly, really. And on top of that, you're going to have all these tags that are going to accumulate over time. Some of them will be very similar. How do you manage that? More importantly, how do you even manage the topics? Maybe we need to merge topics over time or deprecate topics. So, all this is in the back of my mind as I'm thinking about this. And what I ended up deciding to do was, instead of using my topic model to classify posts, as you would traditionally do, I ended up using it just to discover the topics and to create embeddings for those topics, which I then used to search. Yeah? And there are a lot of benefits to this. First and foremost, as you will see, your topic model does not have to be very good. Your topic model can actually be really crappy. It obviously simplifies retrieving documents because you get them ranked in terms of relevance when you search because of the search scores, right? And you can capture topics all the time, and you're not tagging posts indefinitely, right? And my favorite part of this, actually, is that you can actually generate your own topics. You don't even need to have posts in the data set, right? Okay, moving quickly. Embeddings, I know you guys are all familiar with this. How many have used embeddings, embedding models? Yeah, okay. The only thing I want to say about this is, so 30,000 words in the English language, right? We encode the documents that have each of those words. It's a sparse matrix. And then, of course, we do dimensionality reduction, and we get a dense matrix, right? And that represents, that array of floats represents that document in the embedding space. So when we start talking about data stores and vector stores, the term you're going to see a lot is dense vector. That is what you're looking for. Okay, great. I'm not going to go through this in detail, but suffice it to say, and this is important to this talk, if you have an array of vectors, yes, each representing a sentence, let's say, in your document, and then you take the mean of that array, that single vector now represents your document in the embedding space, right? You're taking the mean of all those floats, finding the average, and that's your document, okay? Yes. All right. You can use any embedding model you want. I listed some here. I will tell you this, the embedding model does not matter, especially for short text. I found no difference, don't worry about it. What really matters is pre-processing your documents and turning them into structured documents, really thinking about where are my subheads, where are my breaks, and encoding those in your embedding. That really will make a difference in topic modeling. Things like addresses. Do you really want an address as like 99, a number, as a topic? No, you got to remove those, right? So think about cleaning your documents more and then worry about the embedding model later. Storing embeddings. Okay, this is where it gets interesting. It turns out, over the last few years, most of the databases that probably all of us are familiar with now support dense vectors, right? So Elastic, Postgres has a plugin, pgvector, Redis supports it. And not only that, but they support doing things like running cosine similarity on those vectors on the back end, which extremely efficient and performant, right? Especially for like use cases like a mobile app, right? Okay, so this is the sort of overall system design for this thing. We have a bunch of posts. They're getting created all the time. Every time a user creates a post, we pre-process that post, and we store an embedding for that post on the document vector store, yeah? Also, in the background, we're running a topic model. That topic model gets trained every day. New topics are discovered. Every time we create a topic, we create an embedding for that topic, and we store it in a cache. We retrieve that embedding, we search the vector store, and we get a return of ranked posts. Everybody with me so far? Cool. Okay, training the topic model. Again, there are many ways to do this. Your use case matters. You're going to figure it out. I highly recommend a package called BERT Topic, which I found the documentation alone in that package is really, really useful, even if you decide not to use that. And they have a great sort of representative pipeline, which I found really, really helpful. Couple of things on this. You're going to run through this pipeline, generate your embeddings, reduce the dimensionality, run your cluster model, right? And then after that, usually there's a step where you're evaluating that cluster and using TF-IDF. That is an important step for this particular approach. So pay attention to that and think through what that TF-IDF is returning to you, and I'm going to give you an example. Finally, topic models are notorious for not providing a good way of labeling it. So in our case, the last step in our pipeline is to hit an LLM, get it to label the topic, very nice. Actually works better than you would expect. I do get 3 words when I want it. Yes. Okay. And then the last and most important step in this is that you are going to take all those documents that are assigned to the topic, right? And you're going to turn it into a topic embedding. Yeah? And your initial thought on this is, great, I'm going to take all the document embeddings, and the same as I did with the sentences or paragraphs, I'm going to take the mean of all those topic embeddings, and that will represent my topic. Everybody with me? Okay. Searching for documents. This is an example here. We used OpenSearch, which is forked from Elasticsearch. You can use any of the common databases now. This is very simple. One of the cool things about doing it this way is you're running a semantic search. So it's taking that vector and finding all of the documents that are most similar based on their embeddings to that search vector. But you can also apply filters and simultaneously search on keywords. The one thing I would say about search, though, is if you are searching on keywords, you're doing a lexical search as well as a semantic search, remember to normalize the scores because they're probably using a distance metric. Yeah? In this example, we use cosine similarity for our distance metric. There are other distance metrics you can use. I think that's the only thing you really need to think about and test with your data when you're looking at this. You may want to normalize your vectors before you store them in the data store, right? Depending on the metric that you're going to use. Okay, so I went to test this out. Here's what I did. I had a topic model. It had assigned documents to a topic. And then my hypothesis is that if I did a search most of the results would be documents that had been assigned to the topic by the topic model. Not so, oh my God, it was like next to random, okay? So this is like, the topic was cats. We have a lot of cat posts. I mentioned Linux. And I got everything but cats, right? So I'm thinking to myself, why? You know, is it because my topic model is shite? Well, yeah, my topic model is actually shite. You can see overlapping topics, very low coherence score, yeah? But that actually wasn't it. So when you're searching with an embedding vector, here's the trick. You cannot build the vector to represent the topic as a whole, okay? Because if you do that, it's going to search for anything similar to that whole area. It increases your search area enormously. So you're going to get random results, right? What you want to do is localize that embedding. So you've got to find a way to find the center, to represent the center of that topic, the centroid of the topic in an embedding. And when you do that, your search area is much smaller. Yeah? Okay. So a couple ways to do that very, very quickly. Use that TF-IDF, and there's a class-based TF-IDF algorithm, which I recommend, and pick the keywords. Or you can run cosine similarity if you have long documents and you don't think keywords will be enough. Find the documents that are closest to the topic embedding using cosine similarity, and those documents will likely represent the centroid. Or how about you just shoot all the documents to an LLM and ask it to summarize it, and then take an embedding of the summary, right? Lots of ways to do this. We went with keywords, okay? I tried it again. Whew. 1 in 4 of the documents were actually assigned to the topic. This is good. But better yet, all of the top results were on topic. And even the ones, let's see if I can show you this, even the ones that didn't have any text, right? Hopefully this will turn up. Here we go, here's Linux. And again, like I cannot emphasize enough, managing your documents and doing all the pre-processing you need to do, in this case I used a vision model to caption it, right, is really, really important. Okay, to wrap it up, just about every database has support for dense vectors. Try it out, super fun. Search embeddings need to be localized. The more granular and precise the embedding, the better your results are going to be. And the best part of this system is I don't even need to have documents in my corpus. I can create an embedding, say on the 2024 presidential election, and then as people post on that, those posts will be collected. So references, credits, I do recommend checking out BERT-Topic. I leaned on it. And please contact me. I'm still working on this, so I'd love some thoughts on it. Thank you.